So let's take a look at the roulette wheel again here. And if you want to try these examples on your own first, and then you can take a look at the video afterwards and see how well you did, then feel free to do that, or you can pause the video as we go too. Let's start with the probability of landing on a red or a black space. So that word "or" very important in the question. So we're talking about adding probabilities, and we need to think about whether these events are mutually exclusive or not. In this case, they are mutually exclusive. There are 18 red squares out of 38 and 18 black squares out of 38. We can add those probabilities together. And the reason we can add them together is because they cannot happen at the same time. And so we are able to just add their probabilities. Of course, that reduces to 18/19. You could also use the complement for this one. You could take 1 and subtract the probability that you don't roll a red or a black space. And since there's only 2 green spaces, it'd be 1 subtract 2 out of 38 would also give you the exact same answer. Okay, moving on to the next one. What's the probability that the next 3 spins all land on red spaces? Okay, so now we're kind of talking about 3 events and an "and." These are independent events, meaning the outcome of one event does not determine the outcome of the next. Okay, so the first event, rolling a red space, there's a probability 18 out of 38. Remember that we can multiply probabilities of independent events together. Times the probability you'll get a red on the second, times the probability you'll get a red on the third. Now, of course, you can just choose to take 18 out of 38 and cube that number as opposed to multiplying it by itself 3 times. Now, if you do that, you should get 5,832 divided by 54,872, and we get numbers like that. We often just change that to, it's about, I believe about 10.6% is what you get there. Okay, moving on to the next question, which is related. Find the probability that the next 3 spins are either all red spaces, all black spaces, or all green spaces. I like to think about this example as being about cases. There are 3 cases that we're happy with, and we can add their probabilities together because they're mutually exclusive. You can't have all 3 red and have all 3 black. You can't have all 3 black and have all 3 green. It can't happen the same one. So case number 1's the one from above, which is 18 out of 38 cubed. I should say that that is 9 out of 19. Okay. Case number 2, all black. That has the exact same probability, 9 out of 19 cubed. And then finally, case number 3, all green. It's not necessary to label them case 1, case 2, case 3. I'm just doing that for this example. Okay, there are 2 green spaces out of 38. So 2 out of 38, that needs to happen 3 times in a row. That's the same as 1/19 cubed. So the probability, so notice that although each individual case involved independent events and multiplying probabilities together or using exponents, that in the end I add the 3 cases together as mutually exclusive events. One or the other or the third one has to happen, one of those 2 cases, so that we end up with our final probability of 9/19 cubed, all red, plus case 2, plus case 3, just like that. Now, if you do all of that, okay, you're going to find you should get about 21.3% when you add all those up together. Okay, let's move on to the next one. Actually, before we move on, let's talk about something a little interesting called the gambler's fallacy. The gambler's fallacy has to do with the fact that spinning the roulette wheel, each spin is an independent event. So if we had, for example, 2 red spins in a row, that does not mean that the next spin is more likely to be black. Now let me extrapolate that. Imagine there are 10 spins in a row, all of them red. What does that mean about the 11th spin? Well, it means the probability of it being red or black has not changed. The gambler's fallacy is either that people think, wow, there's been 10 reds in a row, surely a black must come up, or there's been 10 reds in a row, it's probably going to be another red. Neither of those are true. It's just it's a misconception, pardon me, that people have, and that's called the gambler's fallacy. Okay, now let's move on to the next one. What is the probability the next two rolls are both the green zero? So that's this one down here. And there's only one green single zero, so the probability is 1 out of 38. But that's on the next two rolls, so we multiply that together, those two independent events. That's a very small probability, about 1, and well, exactly 1 in 1,444. Okay, so less than 1%. Now I've moved on from that and said, well, what are the probability the next two spins are both the same number? Well, now there's a lot of cases we could look at. We could look at the probability that they're both the green single zero, which we just figured out above. We could also look at the probability that they're both double zeros. Well, that's going to be the exact same calculation. We could then look at the probability that they're both ones. Both twos. You see what I'm getting at here? All the way until we get to the number 36, the last number, the probability of two 36s in a row is still 1 out of 1,444. Now we're happy with any of these cases. This is 38 cases. We're happy with any of them coming up. So adding them all up would give us the answer. Now we don't actually need to add them up because they're all the same probability. We can just say that our final answer will be 38 times 1,444, rather than taking 1 out of 1,444 and adding it up 38 times. We can do this instead. That gives us 38 or 1,444 for our final answer, and that actually ends up being 1 out of 38, which is about a 2.6% chance. There's another way you could look at this one, actually. You could look at it this way. You could say, well, rolling the same number twice, get up there, the first roll happens, you don't care what it is. You just care that the second roll is the same number, and sure enough, there's a 1 out of 38 chance that you're going to get that second number. So you can see that sometimes we can play tricks like that to make questions a lot simpler, and that does make that one a lot simpler. Okay, moving on to the last example. In some ways, this might be the toughest one to understand. What's the probability at least one of the next two spins is a green zero? So we're going to go up, we're going to spin the wheel. What's the probability of the green zero? At least one of them. Well, at first you might be tempted to add these probabilities together. That's the probability I get the green zero on the first spin, plus the probability I get it on the second spin. However, that's not quite correct, because that double counts the probability that you end up with two green zeros in a row, which is really unlikely, but it is possible. This is actually a very good estimate for the probability. This comes back to the idea that the probability of event A or B happening is the probability of A plus the probability of B. Subtract the probability they both happen, the AND. So the probability of A or B is probability of A plus B, subtract the probability of A and B. And in this case, A and B can happen. In other cases, the events are mutually exclusive, meaning that this P and B, that couldn't happen, so we didn't have to worry about subtracting it. So what's the probability they're both green zeros? Well, that would be, we figured this out already, 1 over 38 times 1 over 38. So technically, this is our correct answer. 2 over 38, subtract 1 over 1,444. Now, if I continue with that, find a common denominator of 1,444, times this by 38, so times the top by 38, gives me 76 over 1,444 minus 1 over 1,444. 444 for our final answer, which is correct, of 75 out of 1,444. Now, that's not the only way to do the question. And this idea here, I know is kind of confusing. We don't often need to use it. There's usually a workaround. For worrying about non-mutually exclusive probabilities, there's usually another way to do the question. So let me just show you the other way that you could do this problem. What you could do is you could instead look at the complement. So the complement is the opposite of this. What's the opposite of not one of the next two spins being a green zero? What's the opposite of that is that you don't get a green zero for 2 rolls in a row. So what's the probability you don't get a green zero in the first roll? 37 out of 38. What's the probability you don't get a green zero on the second roll? Also 37 out of 38. And those events are independent. So I'm okay to multiply their probabilities together. The only time I'm not okay to multiply probabilities like this together is if this outcome affects this. And on a roulette wheel, it does not. Now, if you multiply those together, you get this right here. That's the probability of no green zero, which is the complement of what we're looking for. So we could instead have subtracted that and said, okay, well, if this doesn't happen, it means we got at least 1 green zero. And sure enough, we will get the exact same number of 75 over 1,444. Okay, now it's about 5.2%, I believe. That gives you that same answer right there. Now, that's it for this lesson and these examples. One thing I will bring up, some people are having a hard time, I think, with this idea right here. Why doesn't this give you the final answer? 1 out of 38, because I have a 1 out of 38 chance on the first spin and a 1 out of 38 chance on the second spin. Why can't I add those together? Well, imagine a simpler problem. Imagine flipping a coin twice. And let's say you're going to flip a coin twice, and you want at least 1 tail. What's the probability you get at least 1 tail? Well, the probability of getting a tail on the first flip is a half, and the probability of getting a tail on the second flip is also a half. Well, clearly it's not a half plus a half, which would be a 100% chance. There is not a 100% chance that you flip a tail when you flip a coin twice. In fact, the probability is a half plus a half. Subtract the probability that you get a tail both flips, which is a half times a half, or a quarter, and that sure enough will give you a real probability, which is 3 out of 4. Now, that's not the best way to answer that question. The best way is to just think about all the possibilities for heads and tails. Sure enough, there's 4 outcomes. 3 of them have at least 1 tail, the bottom 3. So that's the best way to do that one. All right, I hope that helps. There's some other questions for you guys to try. Good luck with that, and see you next time.